Maybe. We'll see if this works. Okay, I have no idea if this is working. Hopefully it is. So, I've got to get the stream back up and running. We can hear you. Fantastic. Thanks, Sion. And also, a big thank you to Sion because he's been on Discord chatting with me while I've been fighting with OBS and getting everything ready. So he helped me with a few settings and we're finally back. Cool. Looks like everybody can hear me. Now I need a little rest. I very nearly threw my iMac out the window. So, alright, so my general idea for this was that I wasn't going to get too deeply into a whole bunch of technical stuff. And what I was thinking more was just a chance to hang out for a little bit and chat about different things and find out what people are doing during this crazy lockdown time and whether things have really changed all that dramatically for you. It's obviously affecting people in different ways, and you would think that for me personally, because for the last couple of years I've been working from home, I've got this workshop set up, that nothing would really change. So my normal day-to-day is very similar to what I've been doing in the past, but it does still seem to have made a pretty big impact. I'm pretty much in the best case scenario to be able to continue as usual, and it's still been a very big change in many parts of the way my life works, and for other people who are in different circumstances, obviously it's had a much bigger impact as well. And that it's been really cool having the Discord server running because it means that I've been able to interact with people somewhat real time, have chats about different things, and that's helped me quite a bit. So if anyone is wanting to do sort of real-time chat, jump on the Discord server. If you go to superhouse.tv, you will find a link up the top to Discord, and from there invitations are open. You can jump online. Now, to get this started, what I could do is maybe show a little bit about the design that I'm working on. In fact, I'll get Fusion up and running while I'm chatting for the Pro version of the air quality sensor that I've been working on for a little while. Episode 1 is up for the basic version of the air quality sensor, which is just the D1 Mini and the PMS 5003. And I've mostly filmed part 2, which is the display version. In fact, this is one right here. Can you see this? Yeah, so this is the version of the particulate matter sensor, air quality sensor, with a display on top and a mode button so that it can display readings directly locally and also information like the IP address it's been assigned and other handy things like that. So I've mostly filmed that, and one of the things I would like to do is get some feedback on the best way to present the information in it. One thing that I've found as I've been working through doing the filming for this is that it takes a really long time to explain source code, and the video that I've got so far, I've been editing it as I go, is about half an hour long, and probably 20 minutes of that so far is just me going through the source code that runs on this device to explain how it works. And it feels really, really dragged out. So what I'm probably going to do is post a version of the video for patrons first and get some feedback before it goes out live and ends up forever on the internet, because I want to know whether the approach that I'm taking with going through the source code and explaining it is effective and whether it's useful. The real difficulty with explaining source code is that the pace and what you talk about really needs to be tuned to the person that you're explaining it to. And I actually quite like explaining source code or talking through it with someone in person, because you can be very interactive, and if you don't understand something, you can ask questions. Excuse me. But, okay, I've got to go for this. No, it's only a cola beverage. Nothing more than that. But when I'm explaining source code on a video, when I get to a topic such as a state machine, then there is the question of, do I go down the sidetrack of explaining what a state machine is, or do I just say this is a state machine and these are the states, on the assumption that someone has that basic understanding? So, Dodgy says, nasty cough. Something to tell us? Actually, yes, but not COVID-19. Oh, hang on. Can I mute this for a second so that I can cough properly? So maybe not sounding so bad now. Yeah, I do actually have a sinus infection, throat infection at the moment, and I started on antibiotics a couple of days ago for that. It's the recurring problem that I get, and it's just very annoying timing that I happen to have got it right in the middle of this period when all of these other medical issues are going on. Yes. Okay, so let me try to be a little bit more interactive here, because a lot of what I'm wanting to do is actually talk to people and not just have this as me talking and everybody else listening. So, yeah, so Matt said, would the state machine have a visual representation like the X-State visualizer? I've never heard of X-State visualizer. That sounds interesting, but I'm definitely going to check that. So I'm going to have a look for X-State visualizer and find out what that is. So what I'm doing, oh, okay, interesting. So you can put different states in there and you can switch around between them. Yeah, some kind of visual representation like that might be good. So Dodgy asked, did I come up with a formula for how much to explain? And no, I don't really have a formula. What I'm trying to do is go through the source code in a way where I'm not necessarily explaining every single line. What I'm doing is explaining major parts of the code. For example, when variables are declared at the start, I will select a group of variables and say something like, these are the variables that are used to store the values coming back from the sensor so that they can be accessed elsewhere in the software. But then I won't explain every variable individually. And hopefully that keeps the pace at a point where people can follow through the source code, but it's not rushing through. Okay, so, Bedrock said, what's printing in the background? Actually, I can probably kind of show you. Oh, and I can definitely show you, because I can switch to desktop, and I've got Fusion 360 open. Right now what I'm doing is printing an enclosure for a Raspberry Pi with a 5-inch touchscreen. And where is that? I can't even remember where the project is. In here. Oh, it'll be in here. So it's an enclosure that has an Octo screen set up. So this is the enclosure that's currently printing. It prints face down like this. And if I pull up my OctoPrint interface. I can probably even drag that over and get it onto the live stream, which is a bit of a strange roundabout way of doing it, but it should work. So that is the camera feed coming off my OctoPrint setup. You can see that it's just printing a black enclosure there, which will have a 5-inch touchscreen on it. And what it will look like, in fact, I'll pull up a photo and find the end result, because this is actually the third one I've done. And I can show you what they look like when they're finished. Maybe. Where is it? Oh yeah, here it is. Okay. So this, if you can see it, is the setup on my Prusa 3D printer. I've got a few 3D printers, but this is the one that I mostly use. You can see that it's in an enclosure. These are transparent sides on it, and it's the classic lac table enclosure, except that what I've done is I've got a couple of lac tables stacked on top of each other, and I've replaced the legs on the top one to make it higher. That's so that I could have room above the printer to fit the multi-material upgrade, which I'm not using right now. And you can see up here, there is an enclosure attached above it, which has got a touch screen. That's running the OctoScreen plugin. The Raspberry Pi just behind that is what's running the printer. And you can see a couple of cables coming out. There are two right-angled USB cables that come out of the enclosure. One of those goes to the camera. You can see the camera just down here. There's a webcam inside the enclosure pointing at the printer. And the other cable goes down to the printer controller, which is down the back down here. I used to have the Raspberry Pi within the enclosure for the printer controller, but I ended up about a week, 2 weeks ago, moving it up into this enclosure, mounted outside, partly to keep it cool, and also partly so that I'd have the touchscreen that's accessible right up the top there. And what I'm doing at the moment is printing another version of this enclosure in black. So if I go move that out of the way so you can see it. So this is the view from that camera that we were just looking at a second ago. Can I get to control? Double click. Yeah, so this is the view from that webcam, which you can see right there, looking at the printer. And it's doing a version that is going to be running on my my Mendel 3D printer. So my Mendel currently has a version of this enclosure which is printed in blue, because that was the color I had loaded at the time. And I made it a little bit too wide. So the gap between the end of the Raspberry Pi and where the USB cables come in was a little bit long. So I'm just printing another version of it now in black so that I can put it on the front of the printer. Now, I've totally lost where I am here. I've got stuff all over the place. Close that off. Alright, back to the chat. Oh, yeah, so Unexpected Maker asked what plugin is that? That looks very different to the normal camera view. That is the dashboard plugin, I think, in OctoPrint. So, what I'm running is the dashboard plugin and also the OctoScreen plugin. So if I come back to my normal OctoPrint interface here, I'll bring this up so you can see it on the live stream. Yeah, normally I think it's temperature. So when you start when you log into OctoPrint, normally you get this screen showing here with temperature and you've got controls and things, and then you can click across to controls. But I've installed the dashboard plugin, which gives you a whole lot of handy things, and it also brings the camera view up onto the same screen, which I really like, because normally if you're looking at temperature, then you don't have the camera, or if you're looking at control, you don't have the temperature. And there are ways to combine that, but using the dashboard, you can see the current job, what state it's in, and you also get so we're getting live updating layer progress here. You can see it's moving through this layer pretty fast, and you get the camera view as well. And then what you can't see on this view is OctoScreen. So OctoScreen is really cool. I only came across it just maybe 2 weeks ago. What it does is provide a GUI for OctoPrint which runs on the local monitor attached to the Raspberry Pi, and it has support for a touchscreen. So what you can do is, in this particular case, what I've got is the printer is over the back of the room there. In fact, if I switch to my front camera, it's kind of in the way. You can see right over the back there, that's the enclosure with the Prusa that's currently running. And in front of it, sitting on the bench, that's the Mendel Max. So move that chair out of the way. And you can see just down the front there is an enclosure that's got a 5-inch touchscreen on it. That's got the Raspberry Pi in it, which is running OctoPrint for the Mendel, and it's running OctoScreen with the touchscreen. But what I really like about that method is that it means I can access OctoPrint over the network as usual, just in a browser, but it also means that I can walk up to the printer, use the touchscreen, and select an object from the SD card and print it. And that's been really handy over the last couple of weeks because I've been doing a lot of repetitive printing. There are some things where I've needed to print 8 or 10 of the same thing. So I would run a print job, and then I can go over to the printer, clear the print bed, and then just use the touchscreen, select the same thing, hit print, and it just starts again. So I don't have to keep coming back to a computer to then send print jobs to the printer. And that is really handy. So let's see. Yeah, Xeon, you should check it out. That is very handy. My apologies if I'm mispronouncing your name, but Marge or Mai said, for the people that want to understand the code and don't have the knowledge to understand it by just looking at it, you could go quite in depth with explanations. Yes, I'd like to, and this is the difficulty with trying to strike a balance between how in depth do I go versus keeping everything moving along. And it's also partly why I'm experimenting with splitting the air quality sensor project up into a series of videos, like a mini series, which is what I was wanting to do with the network episodes as well, because it means that people can just focus on the areas they want. And my concept was that I would do episode 1 on the basic version of the air quality sensor. I don't have one right here. Episode 2 would be the version with the display. Episode 3 would be the Pro version, which is this one right here, which has got USB-C, there's a PMS7003 on it, there's an ESP32 on the back, and it's got a BME 680 so it can check for volatile organic compounds. This one is a much more complicated project because it's got custom PCB and that sort of thing. And by dividing it up into those 3 episodes, if someone was only interested in part of it, they could just look at that particular episode. So I've been thinking that maybe what I should do is split it up into more than 3, because I also have a whole lot of material that I want to cover about what air quality is and the different national standards that are used to measure it. So there isn't really and accepted international standard. Each country, if you look at at the way they report their air quality, have their own ways of doing it, and they're largely based on the same thing. Like they'll be based on the quantity of particles in the air of particular sizes, but also of different types of gases, and they report them in different ways. So they'll have some kind of a numeric scale that goes from excellent air quality to, you're going to die air quality. But the way those numbers are represented is quite different. So in the UK, it's numbers, I think, like 1 to 6 or 1 to 9 or something. And in other countries, it is in scales that range in hundreds. So the reporting can be quite different. And just talking about that sort of thing could be 20 minutes of content. And I don't want to end up with a video that's going to be hours and hours long, because I'm spending half an hour explaining the source code and 20 minutes talking about air quality reporting and those different things. So I may end up splitting a little bit off. Okay. Oh, Super Johnny 83 says, greetings from Norway. Hey, Norway. It must be a very different sort of weather up there right now. Okay, oh, Ryan asked, is SuperHouse still powered by OpenHAB? Right now, no. I have the logic in the house is pretty much all in Node-RED at the moment. And that started off as an experiment that I thought was just going to be a very quick thing, and it wouldn't be practical to continue with it. And it's ended up being that way for probably the last year. And it's been fine. So originally what I had was, well, not really originally, but for many years what I had was OpenHAB providing things like the knowledge of the state of different devices. And then I had some rules sitting off the side, which was written in a little a rules parser that I wrote in PHP many years ago. And it was linking into MQTT and into OpenHAB using its API. And my idea, basically, of the experiment was to start by taking the existing functionality of the rules engine and replace it with Node-RED, because Node-RED is written by people much smarter than me, and not have to have my own little hacky thing sitting off on the side. And then what I did was, I thought maybe what I could do is add things like state management into what I'm doing in Node-RED, and just turn off OpenHAB and see what happens. So I did it just to see what it was like, and I put the Node-RED dashboard plugin in place, and just started using that on my phone instead. And yeah, a year later, I'm still running it. So partly that was prompted by the OpenHAB, the end of the OpenHAB 1.x series, moving to OpenHAB 2, and I've installed OpenHAB 2 on a couple of devices. That's currently what's running on a Raspberry Pi at Chris's place. So I do have experience of running an OpenHAB 2 system. It's just that I don't have it running in my house at the moment. He's using it. In fact, people might be a bit horrified to hear this, but he's using it as part of the back end for a nurse call system. And what we've done is used a Wemos D1 Mini with a battery pack and a piezo buzzer. So we've made a little self-contained, it's like a mobile doorbell receiver essentially, which can be carried by his carer. And then from the phone attached to his wheelchair, he can go into OpenHAB and click a button, which then sends a message to the little handheld device, and the carer gets the beep and knows that he needs their attention. So it's not quite a critical care system, but it's bordering on that, and we've been using OpenHAB 2 for that probably for a year, I think. So I may end up putting OpenHAB back on my in my house, but we'll see. Okay, so let's see, what other questions do we have? We're all here because we're not all there. Yes, Richard. I think that's about right. All right, quickly scanning down to see if there are any other questions. All right, so Ted the Tiger asked, have I ever talked about the legality of doing home automation stuff in Australia? My last look at it was that any permanent wiring, not extension cords, is prohibited. And the short answer is yes. I did a video about that a little while ago, and it was called Australia, Worst Place in the World for DIY Home Automation. I will find the video for that. It might have just been a vlog, actually. It wasn't a full episode. So where is that? Got it back here somewhere. Oh yes, here we go. I'll just stick this URL in. And so Mike said, Mike Conti says, I've used many brands of automation, and I think that MQTT as a base is going to be a new standard. Then you overlay and interface that with a great GUI. Yeah, exactly. That is really my my philosophy of the way I go about this, is that I treat MQTT as the common backbone that everything else has to talk to. So one of the big issues with home automation is that everybody that makes home automation devices wants to rule the entire infrastructure. They want to be the hub, they want to be the user interface, they want everything to rely on them. And that can be really frustrating if you're using a DIY system or if you're using parts from different manufacturers. And I think what we're seeing now is really interesting that a lot of people are using MQTT because it becomes the common thread or the common way of linking different things together. So I really like MQTT as the glue, and everything else talks through that. So Alan has said, hello from Albuquerque, New Mexico. Hey, any thoughts about linking control of fans, filters, or HVAC equipment? Yes. In fact, I've got a project that I started quite a while ago to access the service port. You can't see it, but just up there I've got an air conditioner here in the lab which has a service port in it. And I did a bit of digging into the connections on it, and a plan that I've had in the back of my mind for quite a long time is to design a little breakout board, probably something with an ESP32 on it, that you can open the enclosure for the air conditioner, just plug the board in, and then talk to it. But I've also done the crude approach of an IR blaster. If you, yeah, you can see it. Just over my shoulder, it's backwards, there. That is the remote control for the air conditioning system, which is on the wall up there. And it uses infrared to control it. And a couple of years ago, in fact, probably many years ago, I did a design of a project. Let's switch over to Eagle, and I'll see if I can find it and bring it up on the screen in just a second. I did like an IR beacon project, and many people have done these. This is certainly not unique. I might have just been called Beacon. I've got so many, there it is. I've got so many Eagle projects that I just lose track of it. So, switching my screen to desktop, and this is a PCB. Which one was this? Oh, particle photon. Okay, so this was a very early one. What this one has is an infrared output, so there's an IR LED on there, there's an activity LED which is visible, and there's an IR input. So that was just using an infrared photodiode. And it's also got a 433 megahertz receiver module on here, and down here there's a 433 megahertz transmitter. Now over here I put on the footprint for a particle photon because that's the particular device that I was using at the time, and it's designed to fit into a little enclosure. And the idea with this is that you could use the IR receiver to decode transmissions from an existing transmitter, and then you could replay them. And because the particle photon has Wi-Fi, this is you could then have it subscribe to MQTT, and then you just send a command and have it send a signal to the air conditioning system to change its state. And I do actually have hardware of that around somewhere. Where would I find it? Probably over here. No, it might be out in the garage because I have, yeah, the hardware for that is out in the garage. I've got so many projects that I've had to shove some of them out there. Alright, now there's a very good question there from YTFP Chris, who says, MQTT is great glue but essential. Do you have any redundant systems in place for critical applications if the breaker goes down? That's a really good question. And redundancy is one of the constant problems with home automation in general and DIY home automation in particular. So having a way to be able to control things, the classic thing that people say to me is, what if you have a blackout? How do you control the lights? And of course, with a blackout, there are no lights anyway. But having some kind of a complex system which you rely on for the lights in your house to work is a legitimate concern. If the Raspberry Pi that is currently running that dies, even something like the SD card, I mean, Raspberry Pi SD cards do fail from time to time, and so it's quite possible that the SD card could fail, my breaker goes down, and of course I'm running Node Red on that same machine, so effectively my whole house would die, all for one SD card that's worth like $8 failing. So allowing for that is important. So what I've got is two Raspberry Pis sitting side by side, and I keep the configuration synchronized so that I can actually fail over to a backup if I have to, but it's not automatic at the moment. I would have to change a few things. I've done work in the way distant past with redundant failover on web servers. So one thing that I've had in mind is some kind of a plan where I have the IP address of the MQTT broker being a virtual address which is provided by one device, or it can be provided by the other device if there's failover. And if you're doing like a dual node system, the classic way to do that is what's called stoneth, or I don't know if people still use that term. We used to use it, which is called shoot the other node in the head. And it's where you have two devices, each with a power supply, and each one of them controls the power supply of the other device, and there is a heartbeat between them. So if one of them detects that the other device is misbehaving or has failed to respond to its heartbeat, it turns off the other device's power supply and it takes over its IP address. That way you can have two devices, and if one of them totally fails, the other one will continue. And the stoneth, or the shoot the other node in the head, takes care of a situation where a device might have partly failed and it's causing problems. So whichever one is live has the ability to kill the other one by turning off its power supply. Yep. So Peter Kirkos said he runs Home Assistant, Node-RED, Hoops, MQTT on a Synology NAS, all under Docker, completely reliable, all on RAID 5 with SSDs. That is an awesome setup. Doing that, there are multiple levels of goodness in that. RAID 5 with SSDs is nice. It means it's fast. You've got the redundancy of RAID, so if you have a single disk die, it doesn't take down all of your storage. Doing it under Docker means that it's in a self-contained, well, it's in a container, and what you can do is, if you have a problem with that particular software, you can kill off the running instance and you can spin up a new container and get everything back up and going again. And Synology NASs tend to be quite reliable, so that sort of architecture is a really nice way of doing it. And Dodgy asked, so was John saying that MQTT is going to get a UI? Not well. The UI for MQTT is really just the its interface. What the nice thing about MQTT is that you can use a variety of UIs depending on what you want to do, and there are general purpose UIs that can be used for testing. Like you can get an app where you put in details of your broker and you subscribe to the broker, and then you can do things like publish to topics just by typing the message in and selecting the topic you want to publish. You can subscribe and see what's being done. But those sorts of UIs are more for debugging. It's just for looking at the messages that are going on the server and figuring out what's happening. It's not the same as something like an OpenHAB or Home Assistant UI running on a phone, which is really slick, and it has different sections for different parts of the house and different types of UI like sliders and buttons that map to different functions. So that is something that you would take care of more within the system that you're wanting to set up, not within MQTT, which just takes care of passing the messages behind them. Unexpected Maker asked, how many Pis do you own? The answer is I don't know. And I've used a lot on different projects over the years that have gone out and been deployed. So over the years I've bought hundreds of them. But in terms of running in the house right now, probably about 6, something like that. So a couple for the home automation system. There's like one in each of the 3D printers. There's another one down the other end of the house. Actually, no, it's probably more than 6. I won't get into that right now. Okay. Oh yes, and Toby Robb said QNAP servers are great too and can run containers. Some have HDMI and terminal options too. Yeah, that's right. So QNAP servers and Synology NASs, they're both excellent off-the-shelf ways to do this. There is a project that I've been working on for quite a while, and I will pull out the hardware for this because it's kind of cool. I'm going to have to switch my camera back to the front, I think, so you can see this more. Now this is an early version, but what you can see here is a Raspberry Pi in a rack mount enclosure, and there is a screen there and there are some buttons. Now this was my first draft essentially of this project, which was the start of making a replacement for my light switch controller. And the design for this has gone way past that point now. In fact, I will switch to Fusion 360 because that enclosure I designed in Fusion 360 and then went off to a metal fabrication place and they fabricated it for me. So what this is intended to be is a system for setting up either a Raspberry Pi or an Arduino, which could be running as the central control system for your house, and you could have a hard disk on it, not just run the SD card. Where is this? Somewhere in here, rack panel, I think this is it. So let's switch back to desktop, rack panel. This one I think will be a reasonable representation. It'll just take a little while to open because it incorporates a whole bunch of sub-projects. So some of you will probably have seen my light switch controller project that I did, a rack mount light switch controller, which was a few years ago now. And ultimately this will be the replacement for that, but it's a huge step up from it. The first one that I did was using a plastic box which I hacked and mounted some RJ45 sockets in it. This is really taking a long time to load. What's going on? I wonder if my stream is slowing this down and it doesn't have it cached locally. Alright, we'll just let Fusion 360 spin its wheels for a while and come back to it. Oh, it did. Okay, one component is out of date. Let's update them, see what happens. So what I've got here is, I'll bring this up, and let's get rid of that panel to make it take up a bit more space. So ultimately this is going to be the replacement for my light switch controller, and so if I bring this one up again, you can see the resemblance there. This is the early draft. There are a few differences with this draft. One thing I did was, my original plan was to have the Raspberry Pi sticking through the front like this, and that took away a little bit of flexibility, because what I wanted to be able to do was either use a Raspberry Pi for a situation where you want to run OpenHAB or Node-RED or something else on this, and that means that your light switch controller could be the whole controller for your house. Like, all of the logic could run on this as well. But I wanted a simpler version as well, so you could just use an Arduino or an ESP8266 or something in there, which is why I revised the design to what you can see here on the screen. And let's just change the camera setting perspective. Oh yeah, that's right. So what you can see is the up here there is a board which has an OLED on it. Oh, and yeah, OLED, not sure, can't remember. But there's an I2C display module in there and menu buttons on the front. And then down here there is a connector which allows a connection through to either a Raspberry Pi or to an Arduino with a shield on it. And then what you can see down here, in fact I'll just spin it around this way so you can see it. This is a PCB with a whole bunch of 8-way RJ45 sockets on it. So this will give you 24 light switch connections, and it also has a pass-through with the Ethernet connection there. So the idea is that this is mounted in the front of the case, which will all be laser cut steel, or actually probably aluminium. I think I'm going to switch to. You'll be able to plug in Ethernet here, which will allow for power over Ethernet breakout as well. We could do that, or you could plug a plug pack into here. And then by mounting it like this, what I can do is use a short patch cable from the Raspberry Pi to go through into this internal socket. So it'll just be a short Ethernet cable going through here, and that exposes the Ethernet from the Raspberry Pi onto the front panel, and it means that the Pi itself can be hidden down inside. And then there's plenty of space here to mount something like a hard disk. So you could run a hard disk connected to the Raspberry Pi and then boot off the hard disk, and then you don't have the reliability issues with the SD card. And by breaking out the pass-through like this, it gives the opportunity to do power over Ethernet as well. So we can do that independently of whatever is plugged in the back here. It also means that you don't have to use just a Raspberry Pi or an Arduino. If you prefer to use like a BeagleBone or whatever other device you might want to put in there, you can. It's just all you need is the mounting holes. So what I've done in here at the moment is I put mounting holes for the Raspberry Pi that you can see, and these are Arduino Mega mounting holes. So you could put an Ether Mega in there or whatever else you want, basically. And there was the question about, can it be daisy chained to more than 24 ports? Short answer is no, because of the lack of addressable I/O. So let me see if I've got, because I've actually fabricated these. Like, I've got these real PCBs. Where is that? Switchboard controller. No, not that one. Here we go. I think. No, not that box either. It's too many to find. Maybe it's over here. Show. No. I think that might be in a box in the garage as well. So I'll show you the different versions of that. Come on, give me that control. Let's see, what else have we got? So this is the 24-way RJ45 board, which is the one you can see there. But if we switch to Eagle, I should be able to find the shorter ones. Where is it? Light switch. Ah, too many Eagle projects. Oh, here we go. Okay, so this one, this one's incomplete at the moment because I was revising it to change the connections. But this one is an 8-port version. So if we go back to what's showing in Fusion here, this long green PCB, this is the 24-port version, and it includes the pass-through for Ethernet. This is an 8-port version, which just has a pass-through. So it's got I2C coming in on one side and going out on the other, and you can daisy chain them. So you can put more of those in, but there is a limitation on the number of addresses that you can have. So the practical limit is 24 ports before we run out of I2C addresses, and then we'd have to run multiple I2C buses. Check Discord. Okay, let me see. Oh, cool. So, there are photos of the board. For those of you that are on in the SuperHouse Discord, James Kennewell has just posted photos of the actual hardware. I put those up some time ago. Yeah, so this is the 8-port version, and then there is a 16-port version, which is this one, and then the 24-port version, which is the one that you've just seen the render of, which is this one. And with the 24-port version, I've got the Ethernet pass-through, and on the other two I don't. So, question from Duncan has said, when you say 24 port, does that mean 24 by Ethernet ports? It means 24 RJ45 sockets, but they're not Ethernet ports. So what I'm doing here is using RJ45 and Ethernet cabling to connect to the light switches, but I'm not using Ethernet as such. I did have it, and part of the reason for this is that I originally had Ethernet running to every light switch in my house, and I was using power over Ethernet, and then at every light switch was a device which was essentially an Arduino with Ethernet on it. I was using Ether 10s, which is actually why the Ether 10 was designed, and what it would do is when you pressed a button at the light switch, it would send a message over Ethernet to MQTT, which would then have an effect. And so when I switched my home architecture over to using just simple buttons at all of the light switch locations, all of that Ethernet cabling was in place. And so I changed over to using RJ45 connections. So what this means is that each of the sockets that you see on this device, which looks like an Ethernet socket, would go out to one light switch location somewhere in the house. Now, let's see. Someone just asked where the Discord is, and the easiest way to do that is to give the link to the page where the invitation is. So, Marge said, I guess you could use one of those I2C switch splitter chips to parallel multiple of these onto one I2C bus. Yeah, and you can run multiple I2C buses depending on what you're actually connecting into this. So Stephen asked, is this making use of the A and B channel interrupts per chip? And the very simple answer is yes, but it's a conditional yes. What I ended up doing, if I remember correctly, because it's a long time since I've looked at this design, was I chained the interrupts together so that you could tell when an interrupt occurred, but then you would have to poll the chips to find out which one it was, which should be very quick. And let's see, oh there it is, int. So this is the header. Am I still on? Yep, still on the right screen. So that's the interrupt, which comes from the chips. And then in here, we've got int A and int B on here. So by way of background, just to explain what's going on here, this particular chip, so the MCP23017, is an addressable I/O chip. It gives you up to 16 I/O lines, which you can treat as either digital inputs or outputs, and you can control it all over I2C. And there are libraries for this for basically everything. They're very well supported. And so what I'm doing is exposing the light switches to these inputs, and then using the Raspberry Pi or an Arduino to detect when one of these inputs has been triggered, and that's how you know when a light switch has been pressed. Now, you can do that in one of two ways. The code can either scan the interface chip in the loop, so very quickly just checking each of the inputs and see if the state has changed and then act on it, or it can use an interrupt. And so with the interrupt method, what happens is that your microcontroller just needs to pay attention to the interrupt pin, and it doesn't need to keep scanning all of the inputs. When the I/O chip detects that the state has changed on any of the inputs, it then asserts the interrupt pin, and then your microcontroller can start paying attention and come back and find out what's going on. Now with this particular chip, the MCP23017, you can see that there are two interrupt outputs here. There's int A and int B. That is because the 16 inputs are arranged into two ports. There's port A and port B. And you can also configure it so that the interrupts will detect different states, like a state where it's on a rising edge or a falling edge or a change and those sorts of things. And with all of the inputs on port A, that triggers an output on interrupt A, and all of the inputs on port B triggers an interrupt on port B. But there is a really handy little thing you can do in the configuration for this chip. When you initialize it, you can send a config value that tells it to link both ports together for interrupt purposes. And that means that I have totally lost my chat interface here. Got to find it again. So what that means is that if you have an event that happens on port A, it'll assert the interrupt A, but you can also have it assert interrupt A if there's an event on any of the B inputs. So what this means, summary is, you can have a single interrupt output that will be asserted on any of the inputs. Now, because I've got a few of these chips all on the same bus, what I'm doing is just linking the interrupt output together for all of the chips. So when you press one of the buttons on a light switch, the interrupt for that particular chip will be asserted, and then the microcontroller will see there's an interrupt, but it won't know which chip caused it, and it obviously doesn't know which port. It's just saying something has happened somewhere. And then in the code, it can just query each of the chips very quickly and get the state of the registers for all of the inputs, and then see what's changed. So the result is that the ideal situation would be to have interrupt A and interrupt B from every chip taken all the way back to a separate I/O line on the microcontroller, because then it would know down to the port where the event had happened. But this is a bit of a compromise. What it means is that I only need a single input on the microcontroller, and I can have 24 light switches, and then each light switch can have up to 4 buttons on it. So that's 96. Essentially, it's 96 light switches that you can have connected to this controller. And when any of them is asserted, the controller gets a notification and then finds out where it is. So it's better than having it scan every single input continuously, but it's not quite as good as having a separate interrupt for every port individually. Now, I really need to find this chat screen because at the moment I can't see. Oh, I think there it is. No, that's not it, because I can't see any of the chat right now, which means, oh, there it is. Excellent. What have I missed? So, Sausage asked, have I seen the Olinex ESP32 PoE ISO? Yes, I actually have one up here. I have a long-standing interest in power over Ethernet, so whenever anything like that comes up, like any sort of board with PoE, I usually order at least a couple so that I can see what they're doing. So Dave Grants says, I've been using TCA 9548 a PWR to multiplex 8 I2C buses. Works great to allow a lot more MCP23017s. Cool. So if I wanted to be able to multiplex more buses, that would do it. Yes. Duncan said, when do I think these will be available? Has anything changed on the setup side for relay driving? Right now, nothing has changed on the relay driving side, but that is in the cards as well. I've done quite a few different things for relay driving. But back to the first question, when will this be available? When I get to do a video about it. So relay driving. Let's see. I did a. Oh, that's right. It's up here. This is a project that I did some years ago and have never actually done a video about it. This is a DIN rail mounted, let's switch back to main camera sources. So this is a DIN rail mounted output controller which incorporates an ESP32 and 8 relay switched outputs. It's kind of like a, if you've seen the Sonoff Pro, it's kind of like that, but with 8 outputs instead of 4, and an ESP32 instead of an ESP8266, and it's also got the display on the front, so you can show the state of things. And this fully works. It's obviously not certified for use in Australia, but it's all been tested and does what it should. So my objective had been to use something like these in my switchboard, but without certification. Obviously that's a roadblock, and I got a fair way along with this and looked into what it would take to get it certified, but other things got in the way. Let's see if I can open this up to show you what's inside it. And you can also see that I got the buttons rotated 90 degrees from where they should have been, because the caps for the buttons, I actually designed the PCB before I received the buttons that I'd ordered, and I didn't realise that the caps were only able to be installed in one direction. So in here there is a relay control board down the bottom, and that's got a high-link power supply in here, so it takes power off 240 volt mains and generates 5 volts output, and this ribbon cable is linked up to the control board, which sits up in the top of the case. That's got the control buttons and the OLED on it, and the ESP32, which you can't see because it's on the other side of the PCB. So it isolates the mains, which is all done on this bottom PCB, from the control, which is all done on the top PCB. And the plan is you can just mount that in the switchboard, and then you can manually turn outputs on and off for testing or whatever in the switchboard. It displays events here. It's got firmware on it at the moment that subscribes to MQTT, and then you just publish into a command topic and you can toggle the outputs. So it basically just behaves like a Sonoff running test motor, but with a display and 8 output channels. So chuck that back in there and put it to the back of my mind again for however long that ends up being. But just coming back to the controller for a second, this is an Ethernet extension cable. So one of the things I was intending to do is, for versions of this that don't have the Ethernet pass-through coming through here, I could do a version of the case that has a hole cut for it so that this mounts in the enclosure and it exposes the Ethernet on the front, and then the cable here just comes around and plugs into the Raspberry Pi or whatever device you have internally. Now, how many people on this live stream have ever heard of a device called a Cobalt rack? Okay, any Cobalt fans? I love the Cobalt rack. way back in the mid-90s when I had a web hosting software company, coat rack. Cobalt came out with used to have a rack too. All right, for those that haven't seen it, I'm going to be back in a moment. I think I have them in my garage. And I do. So, this is which one is this? Yeah, this is a rack 2. See if we can get some lighting on there. These things looked really sexy when they first came out. I saw one at a computer show somewhere and thought that is the coolest thing I've ever seen. Basically, it's a Linux box with Apache and a web-based management interface, all in this nice little enclosure. And it's a single rack unit. It's got Ethernet and serial console and stuff on the back. And so we ended up using these at my internet company years and years ago, and I still have 2 of them sitting out in the garage. Now these days are so slow that they're just not even worth firing up. It's like I think this one was a 250 megahertz MIPS processor, and it used to run a version of Red Hat, I think. But the thing is that I like these so much that I've hung on to them just because I find the design of this to be kind of inspirational. And this is what I had in mind when I started working on this. So you can see there's a little bit of family resemblance. The look is quite different because one of them is colourful plastic and the other one is just shiny metal. But the idea of using the navigation buttons here with the display, and my current version of this has a bigger display than this. It's not this large, but it's bigger than what's on this first prototype. And what I wanted to do when I was setting out on this project was to take this concept of an appliance that you can just plug into the rack, power it up, and then start configuring it, and try to do that sort of thing as a light switch controller. So that's where the design came from. And what I need is something like a giant 3D printer so that I can print a nice translucent front panel to go over that. Yeah, Sion said the Cobalt racks were so expensive. Yes, they were. They were very expensive. They were kind of groundbreaking at the time because they really introduced people to the concept of a web server as an appliance, because up until that point, setting up a web server was very much either a DIY project or you went out and bought very expensive stuff from one of those big name companies. Like people were running IRIX and that sort of thing for their web servers. So having a web interface, like a web management interface on an appliance type server was really cool. And we ended up, at my company, we ended up writing our own management interface, and then lots of other people did the same thing. And the entire web hosting industry went that way for a while before virtualization took over. And then it all moved into a different place. Okay. Ooh, Mike says I could laser cut you one. Yeah, my laser cutter, just thinking about the width. So a single rack unit is about 400 and something millimeters wide. I could probably rack mount I could probably laser cut one in my cutter. It would be pushing the width, but it wouldn't have the nice curves and things on it. Yeah. What is that 2D code in the transparent box behind you? Oh, this one? Is that what you mean? That is part of a system for locating locating things on the shelves. I'm just trying to find. I can show you what I mean. That's for a project where I have an index. Let me see what I can find that I can actually demonstrate. I should be able to. Now, partly what that's related to, oh, you can't quite see it. Oh, here we go. Storage index. So, drag this across onto this screen and switch back to desktop. So here you can see a spreadsheet, and then you can see number down here and what's in it, and then whether it's a customer project or parts or a product or whatever. And then that's a big list of boxes, and it goes on and on. So these are all of the storage boxes, and this code here, it says code 49, is this one right here, DIN switchboard controller. So it's a way of referencing what tub has what project. And that's the start of it. But the reason that I have these codes here, which are called Aruco codes, they can be recognized by OpenCV, which can then return coordinates. So let me find something relevant to that to show you what happens. The point of all of this is to be able to find where tubs are. So if I know what I'm looking for, I can find it. Somewhere here I have some photos. I've got to scroll back through a whole bunch of history to find it. And it may not even be here. Sorry, listening to me scrolling through a photos directory is not very interesting. Back here somewhere. If I can't find the photos, I'll just describe it. Alright, so if I switch back to the front camera, and you can't quite see it, but right there, well, you can see that there's a wire. See that black wire that's running up there? Up on top of those drawers, so this is all parts drawers mounted on the wall, that is just above head height there. There is a Raspberry Pi with a Pi camera, which is looking straight across the room, and it's pointing at my overhead shelves. And the shelves are where these containers are normally stored. And what it does is take a photo using the Pi camera, and then it uses OpenCV to search the photo for all of the Aruco codes. Then it returns the coordinates of the code that it finds. Wow, I wish I could find. I got pictures of this with the codes overlaid. But where this is going is, I want to be able to just, hang on, I'm just going to mute it. No, I won't say the word because it'll wake up all of your voice assistants. Oh, hang on, I think I might have found it. Is this it? It's not an annotated one. Okay, so I switch back to my desktop. So the view from the camera looks like this. So this is a photo that was captured by the Raspberry Pi, and you can see the codes on these tubs that are here. And then what it can do is process the photo and generate the XY coordinate of each of the codes, which can then be referenced back to the spreadsheet of where they are. So let's find, no, just trying to find one that's got the markup overlaid onto it. No, this is just photos without the markup. Nope, I would have to do some searching for that. Let's see what I can find. I may still be able to find it. Oh, I don't know. I'll have you sitting here bored, waiting while I search through things. I wonder if it's on my Ubuntu machine. Just looking up at another desktop. No, can't see it there. Oh well. Yeah, that's a project to talk about another day. But the result of that system is being able to find any tub anyway. It's the summary. Okay. Oh yeah, so Toby said, is that the one with the laser pointer that points to the boxes? Yes. Where is that? So, for the box locator, this is the little pan tilt thing, which at the moment has, so there's an Arduino here, which has got USB, and then that plugs into the Raspberry Pi, which is sitting up there, and then the Raspberry Pi, when asked for the location of a box, can send over the serial port to this, the location, and this is two servos and a pan tilt mouse, so it can scroll around and go up and down. And at the moment, as you can see, I've just got there's a paper clip blue tacked onto this, so it acts as a pointer. But the objective here is to stick a laser pointer on here and then control the power from the laser pointer with the Arduino as well. And then the idea is that all you do is say, where are my, what am I looking for? Where are the cable ties? And have this just use the laser pointer to point at where the cable ties are. But that's a project for another day. Too many projects for another day. Alright, so something I'm curious about is how many people here well, I was going to ask about something I probably shouldn't. So rather than me just talking more about random projects, I just wanted to know about how people are going. Like, is everybody having a reasonable time of it at the moment? Are you going nuts? Do you have kids that are home from school and they would normally be at school and they're driving you nuts? Yeah. Okay. Good question related to that last one. Fabian said, do you use some warehouse management system to check your component stocks, something like PartsKeeper? Right now, no. And I've thought about that in the past. Xeon has a project. In fact, is PartsKeeper Xeon's project? Xeon, are you here? Still, PartsKeeper. I know there are a few of these projects around. PartKeeper. My parts. Yeah, so Xeon's project is my parts, and that's not out yet. Yeah, so PartKeeper I did actually set up a while ago, and when I was working on this, I think PartKeeper is written in PHP from memory. I can't remember. But I do remember there was some inventory management system that I set up where I got the OpenCV code to, I've got basically a wrapper code which calls OpenCV, and it just gets back a whole bunch of XY coordinates and IDs for the different containers. And then the idea was to be able to push the XY coordinates into the stock management system so that you could always find it that way. But I haven't gone down that track yet. So, okay. So Kai the Wolf says, going nuts, work from home means electronics hobbies that happen in the same office feel like work and motivation dies off. Yeah, that can be quite a problem. On reduced hours but still working. Yeah, this really feels like a major change of the way things are done. It's tending to unbalance things that you would not expect to have been changed. So Sion says, struggle is freight getting worse and having trouble getting components. Yeah. Where things seem to be very strange right now, and I think some of the effects we're not going to feel for quite some months. So when I'm doing small run PCBs, I normally use a company called All PCB, which is in China, and I think they might be near Shenzhen, which is right down the south, and they are now back pretty much in full operation. As of about a week ago, their lead times seem to have dropped. When they first came back, their lead times on PCBs were really long, but they've dropped back down now to the usual sort of 48-hour, give or take, turnaround. And I've got three new board designs that I ordered, including an updated version of the air quality sensor. And they produce those boards fairly quickly, but then DHL shipping seems to be really slow now. So previously I would be able to get a board from China to Melbourne in probably 3 days, give or take, and now it's taking more like 8 or 9 days for the same thing. So it means that things are a bit delayed. Hopefully, once things like screening procedures are sorted out, then the shipping delays will come back down again as well. But I think what's going to happen, or what I've heard a few people talking about, is long-term ripple-on effects, particularly with things like parts supplies. With things like PCBs, they tend to be fairly rapid turnaround, and they're done to customer requirements. It's not a stock item. So if a PCB factory is back up and running and I send off a design and they're in normal operation, I can get those back within something close to the normal time frame. But what's going to be really interesting is what happens a few months from now when we start to see the effects of things like I'll just pick something, say resistor factories, or companies that make inductors or displays or whatever. If they've had big interruptions over the last few months in China, and then they're going to end up with a production backlog, we might see price jumps on jelly bean parts. Things like buying reels of resistors might end up just costing more or not being available at all. So the difficult time for small-scale electronics manufacturing might actually be still in front of us, even though China is now mostly back to work. It could be down the track that we start to see the effects of the supply chain being emptied out, and factories that are normally topping up the supply chain from the back end that have been offline for a couple of months when normally they'd be in production, that will start to flow through. But I have no idea if that's going to be real. Nafla just said, I work in industrial automation. Some parts lead times have increased dramatically. That's interesting to hear. So that's, caps are already going back to shortage days pricing again, Sion says. Yeah. So, hopefully it won't knock us around too much. I'm kind of interested, Nafla, if you can, are there any particular parts that you've had problems with? Sion said capacitors are going back up in price. But if the lead times have increased on some things, that's interesting to know. Oh, yeah. Well, there are some good side effects. Tom George just said the road toll is already down 9.2%. I've heard, and then we've seen things like the air quality improving. It's interesting to see the side effects of this sort of change to the way society operates. Things like, I've heard people say they normally refuel their car once or twice a week, and it's been 6 weeks since they last went to a servo. And there's been speculation that other diseases that are normally transmitted within the population will see a major decrease as well, like just regular flu and other things that get passed around because of the isolation. All of those sorts of things are largely going to disappear. So we're going to see some interesting both positive and negative side effects of this restructuring of society. Toby says, been working at home for the last 19 days, remoting into work 8 hours a day, sheds cleaned, veggie gardens tended, projects getting done. It's really good that you've been able to get through some things and get some stuff done. But I've seen very different responses from people. For some people, and it sounds like you're one of them, these changed circumstances mean that you might be able to get through things that you wouldn't otherwise. And of course, there are things like travel time. If you were previously driving an hour to work and an hour home, then you've just saved yourself 10 hours a week that you're no longer commuting. But for other people, it's put enormous pressure on, particularly people who have kids at school and who are now having to try to supervise schoolwork during the day. That can be really tricky. I know a few people have had some issues with that. So that could be, looks like I'm being I'm being called for lunch. So I'm going to go in a minute because of the late start. This has ended up running on. But now that I've finally got my computer working, I really like the idea of doing more of these live streams. So I'm probably going to try doing a live stream maybe once a week as a way, not just of talking about projects, but just general chat about stuff. And if you do want to interact more, Discord is a really good way of doing it. So I've got Discord shown on one of my screens up here. It's just permanently in my view. So if you jump into the general channel and just start chatting there, that's cool. Oh, see, I just said home break-ins down 100%. Yeah, interesting. So, what was that? So, $1.45 US a gallon. What's happening to fuel prices? Is it going up or down? I don't know what $1.45 a gallon is. Is that high or low? Doji says we're around $4 at the moment. So before all of this happened, we were sort of around the Australian dollar $50, $70 mark per litre. So I don't know what that works out to in US dollars a gallon. But I am going to go. Oh, here in Ballarat, $1.10 a litre today. That's low. So I am going to go and get some lunch, and thank you for being patient and jumping on this chat, on this live stream that was very delayed. Next time I'm going to try to be a lot more organised, and now that I know the audio is working, I can get straight into it. What I can also do is do a little bit more setup in advance. I have, if I switch my camera over to the side, so you get the view here, I've got my microscope here, which has got a camera on it, and that is running, I've got HDMI out, which is running to a game capture device, which is then connected into my computer, so I can live stream from the microscope as well, and maybe we can have a look at a few things on future streams. So I'll get all of the different things set up in OBS so that I can switch between the microscope and screens and cameras. And I've also got to get something better than this camera. Right now, what you're looking at is the camera that's built into the iMac, which seems really crappy. The preview that I'm getting at least looks terrible. So I might try getting a better camera set up for that. Crack open a stuffed IC, Tom says. Cool, that's an interesting idea. Oh, and Dodgy said, how about introducing your wife next time? No, I don't think she wants to be on the live stream. She would hide from the camera. Victor said, where is a Discord link? I think I might have that in my... Yes, I do. So this is about the last thing I'll leave you with is the Discord link. Go along there. There is an open invitation. And thank you all for coming. I will see you next time. Now I've just got to remember how to actually end this live stream in OBS. I'm going to go here. Thanks. See ya.